We release that water is necessary for love. Without water, it seems hopeless to have good quality of love. Currently, many areas in Chiang Mai and Lamphun provinces are facing a drought problems, especially in the dry season. The problem is due to urban development and increasing population which leads to higher demand for water use. The Royal Irrigation Department (RID) has been concretely developed the water resources projects in the Ping River Basin for decades. So far, there have been 3 successful irrigation projects in the Ping River. They are Mae Tang Veer, Mae Ngat Sombunchon Reservoir, and Mae Gwong Udom Thara Reservoir projects, all of which supply water to irrigated areas of more than 500,000 rai, or 80,000 hectares in Chiang Mai and Lamphun provinces. While the average annual runoff of the Mae Tang River is 622 million cubic meters. That of Mae Ngat Sombunchon Dam is 332 million cubic meters. Despite the great capacity of Mae Gwong Udom Thara Reservoir, water stored in the dam is so little that it is not sufficient for the consumption demand. Even in the rainy season, water has never reached the maximum capacity of the reservoir. So far, the water volume in the Mae Tang River is sufficient to be irrigated to the right main irrigation canal of Mae Tang operation and maintenance project for the entire year. During the rainy season, July to November, a large quantity of water in the Mae Tang River will be released to the Ping River, resulting in flooding in Chiang Mai City, as it used to happen in the past. Each year, Mae Ngat Sombunchon Reservoir supplies sufficient water to the irrigation area, thanks to its wide catchment area, which can store more water than Mae Gwong Udom Thara Reservoir. According to the water demand statistic of Doi Saket, San Sai, and San Kamphaeng districts, Chiang Mai province, and Ban Thi and Mueang district, Lamphun province, the present annual water demand from Mae Gwong Udom Thara Dam is 258 million cubic meters, while the water shortage is 136 million cubic meters. In the next 20 years, the water demand will increase to 386 million cubic meters annually, and the water shortage will be 173 million cubic meters. Based on the cost-benefits analysis and environmental impact assessment, the construction of a new diversion tunnel to deliver the excess water from the Mae Tang River to the Mae Gwong Udom Thara Reservoir is the best solution. In regard to the fact Mae Gwong Udom Thara Reservoir inflow augmentation project, Chiang Mai province is initiated. This project is the construction of the diversion tunnel, with a total distance of 49 kilometers approximately. The project is divided into 2 phases. The first phase is the construction of the diversion tunnel, connecting Mae Ngat Sombunchon Reservoir and Mae Gwong Udom Thara Reservoir. The diameter of the tunnel is 4.2 meters, and the distance is about 23 kilometers. The second phase is the construction of the diversion tunnel connecting Mae Taman River and Mae Ngat Sombunchon Reservoir. The diameter of the tunnel is 4 meters, and the distance is about 26 kilometers. The 2 phases comprise disposal area for excavated materials from the tunnel and appertaining structures. The Office of Construction Project for Large-Scale Irrigation 1, the Bureau of Large-Scale Water Resources Development, RID, The Ministry of Agriculture and Cooperative are responsible for providing the constructors to carry out the construction ofแม่แตงแม่งัด Division Tunnel, which is divided into two construction contracts according to procurement in the section of the contract. สยามพันธ์วัฒนา Public Company Limited is responsible for completing the construction within 1,800 days with a budget of 2,134 million baht. แม่แตงแม่งัด Division Tunnel, the total length of about 26 kilometers in the responsibility of the contract, starting at kilometers 13 plus 600, 2 kilometers 25 plus 624 to finish at the tunnel. Outlet structure at the end of the tunnel, located at the edge of the Mae Ngat Sombunchon Reservoir, which will proceed with all 10 construction activities. Activity 1. Construction of access road. In this part, 4 roads are constructed. 1. Road maintenance work for pumping structure of Mapping River Siphon Tunnel, paved with asphalt. It's 8 meters wide with a length of 170 meters. It is connected to the National Highway number 107 for easy access to the construction site for pumping water out of the Ping River Tunnel. 2. The maintenance road of 88 number 484, paved with asphalt. It's 8 meters wide with a length of 1,040 meters and connects to Ban Majo Mu 1. 3. The maintenance road of the disposal area number DA3/1. It's 8 meters wide and 424 meters long. Connecting the maintenance road of 84, it is used to convey disposal materials from the tunnel to the DA3/1 site. Activity 2. Construction of pumping structure of Mapping River Siphon Tunnel. Start to clear the construction area. Slow protection construction. Improve foundations around the pump shaft of the structures. Drill the shaft of the pumping structure using the vertical drill and blast method. And constructing a pumping structure with securely reinforced concrete in a diameter 10 meters. Install vertical inline pump type that can pump 90 cubic meters of water per hour. The pumping structure of Mapping River Siphon Tunnel is used for pumping the water from the Ping River Tunnel to go down to perform the maintenance of Ping River Tunnel. Activity 3. Construction of 88 number 4, 84. 84 is 577.763 meters long with a diameter of 6 meters. The end of the tunnel is separated into the upstream and downstream to connect with the Division Tunnel. Drilling begins with the slow protection work at the tunnel portal by shotcrete install soil, bolt, rock bolt, and strengthen the tunnel portal with four-pulling work and a steel arch. The drill and blast method is used for excavation of 84. It starts with a geological survey, followed by drilling for four-pulling and filling cement model to reinforce the stability of tunnel sealing, geological mapping and marking, drilling. Holes are filled with emulsion explosive prior to the blasting. At this step, The tunnel contains dust and gas caused by the explosion. So, ventilation is needed after that. Scaling and marking is done using shaft. Loaders and material are conveyed by trucks. Finally, strengthened by steeling a steel arch. Installing wheel mesh and chartgrate. Install rock bolt according to the form specified in accordance with the rock mass type. The 84 are constructed to hold mark out of tunnel because there are a lot of loose rock during the drilling process. It is necessary to remove it from the tunnel, transport it for disposal. Activity 4. The duration tunnel starts from kilometers 13 plus 600 to 25 plus 624 kilometers. The duration tunnel, as per the contract, is 12.400 kilometers long and 32,400 meters below the ground level. We will drill through the 84 and pumping structure of Mipping River Siphon Tunnel. We will excavate it using two techniques. First techniques from kilometers 13 plus 600 to kilometers 20 plus 462. The tunnel at the intake structure and the entrance and exit of the 84 will be excavating using the drill and blast method. The drill and blast process starts with the same procedure of the tunnel and strand excavation. The inner surface is covered with concrete lining to increase the efficiency of water flow. Second techniques from kilometers 20 plus 584 to kilometers 25 plus 624. The entrance and exit of the tunnel 84 will be excavated using the second techniques of the tunnel boring machine TBM method. After that, staff will remove cutting head wheels and all components of the TBM to the construction site in front of the entrance and exit of the tunnel 84 for assembly. It is divided into two parts, TBM front shield and TBM tail shield on the assembly area in front of tunnel product. On the other side of the area called segmental concrete lining factory, the team has provided a location where segmental concrete lining is produced to meet the standard of normal and heavy type geological data. After the TBM assembly is completed, the first inward segmental concrete lining and others until reaching TBM launch tube will be installed by the elector as part of a backup component so that the drilling bit is positioned to start the excavation. Then the drilling bit pushes the gripper to TBM launch tube while that is prepared at the final 14-meter section. Due to the cutter head drilling, it makes full face excavation. When the cutter head is completely screwed, it pushes main truss cylinder. The drilling bit is pushed into full face excavation and rocks are cut by a cutter head, mark its way by the conveyor belt, to be transported outside the tunnel by the rail system. Afterward, the holding of the gripper is drawn. A segmental concrete lining is installed to support the drilling bit to remain its level for excavation. Then, all compression forces are removed while the drilling bit is moving forward to reach the required position. To repeat the excavation process, the drilling bit is again held by the gripper. As full backup components, a segmental concrete lining will be installed and transported from the outlet product to the drilling bit. Then, segments will be arranged in the order in accordance with the installed position and type of segments. At the end of shield, After the installation segment concrete lining, injecting cement mortar onto the tunnel's floor is obligatory. Then P. Gravel. It's put into the gap between segment concrete and the tunnel wall. The contact grouting is applied to proceed with cement mortar. All of these steps relate in sequence and excavation process will continue like a loop. Activity 5. Construction of tunnel outlet structure. Tunnel outlet structure at the end of the water tunnel will be located at the end of theแตง-แมwater tunnel at the edge of theแมdam reservoir responsible for releasing water intoแมสมบูรณ์ชน dam reservoir. It's an energy separator structure to prevent erosion around the edge of the basin from the water discharge. The structure width is 6 meters, 10 meters long. The size of the gate is 4 meters. The maximum water rate of flow is 28.50 cubic meters per second. Activity 6. The disposal area number 2, DA2, is constructed. The disposal area is about 48,000 square meters. We use this area to dispose of excavated materials from the tunnel, which will be placed in a stepwise area to prevent the collapse of materials layers. Activity 7. The disposal area number 3/1, DA3/1, is constructed. The disposal area is about 88,000 square meters. We use these areas to dispose of excavated materials from the tunnel, which will be placed in a stepwise area to prevent the collapse of material layers. Activity H. Electricity system is constructed. The power system includes two parts. 1. To extend the 22 kV high voltage lines from to the National Highway number 107 with 160 kVA. Transformer and main electrical system control cabinet, which will be electricity provide light and forward to the pumping structure of Mapping River Siphon Tunnel. 2. Expand the area of 22 kV high voltage. Utility poles and power lines are installed along the road to add it for electricity provide light and for construction. Activity 9. The tunnel deformation monitoring. This activity is a survey work of the tunnel wall during the working process to check if anything changes and how much it changes. The activity includes two techniques with arc drill and blast and TBM. Activity 10. Dewatering during construction. All these activities will take 1,800 days.